Hello everyone. Hope you're having fun working on your strategies and scripts for this CodeWars V4. Today to offer some further insight into the game and how your scripts work, we're going to be trying to understand what exactly game iterations are. Now, right off the bat, there are multiple terms used all throughout the documentation and in our messages and such to refer to this. Sometimes we use iterations, sometimes we use frames, sometimes we use cycles. In fact, if you look at the documentation, the game overview section, especially in the islands, you'll see that over here we've written if team exclusively occupies any island for 150 continuous cycles, they capture the island. So we use these terms interchangeably, but for the rest of this video, we'll be referring to them as iterations. But yeah, all three of these mean the same thing. So what is an iteration? To put it simply, an iteration is a unit of time. You would know that a game lasts 3000 iterations, so it helps measure the progress in the game. But what exactly happens in an iteration, we will be covering with the help of an example. Other than this question, we will also be answering when and how functions are run in an iteration, and whether any of the two teams, red or blue, have an advantage in the game. Now, not to keep you in suspense, so I'll be answering both these questions right now. In an iteration, first, both the red and blue team run their act team function, after which every pirate on both teams runs their act pirate function. But as you will see, no team in this process has an advantage over the other. Now let's look at the scripts involved in our example. Here we have the red team script. As you can see, it's a very simple script. Act pirate just returns a random integer from 1 to 4. This corresponds to random movement with no logic behind deciding which direction to move in. If you look at the act team function, you can see that build walls is called with the arguments 1, 2, and 3 separately. This corresponds to trying to build all possible walls on the map around each island. This doesn't mean that the walls actually get built, and we will see this in the example. But for now, let's move on to the other script. Now here we have the script of the blue team. Immediately you can see that there's some logic involved in that pirate function now. The pirate investigates the tile directly above it using the pirate investigate up function. It uses the return value of this function to check if on the tile above it there are any other pirates. It does this by checking if up1 is equal to blank. If that is true, then it moves into that tile. Otherwise, it randomly selects some other direction to move in. Act team is the same as the red team. Now let's start looking at the actual game running. For this example, I'm only taking a 4x4 map with one island, two red pirates and two blue pirates. Let's assume the iteration is currently number 100. Obviously, this is a randomly chosen number. It doesn't really matter. But this is the game state right now. You'll see that one of the red pirates is on the island, while the remaining pirates are off the islands. The first thing that happens in a game iteration is that the act team function of both the red team and the blue team is run. If we look at the act team function of both teams, we'll see that both teams attempt to build walls on island 1, 2, and 3. In our current example, we don't really care about islands 1 and 3, but we do have island 2. If we look at the documentation of the build walls function, we'll see that it only attempts to build a wall on the island corresponding to the argument it is given. There are some conditions that the team has to satisfy for the wall to be successfully built. Firstly, the team should have the required resources. Secondly, the team should be the only team that is present on the island. That is, all pirates on the island should belong to that team. Also, the cooldown should be complete, but for our case, let's assume that the cooldown is complete. Now, if we look at the map, we see that the blue pirates are not capable of building a wall on island 2. This is because the blue pirates do not have sole occupancy of island 2. In fact, it is the red pirates that have sole occupancy of island 2. So if we also assume that they have all the wood they need and the cooldown is over, the red pirates will be able to build a wall on island 2. So when the red act team function is called, build walls 2 will successfully complete and the red team would have built a wall around the island. Now, the thing is, you might be wondering, won't it matter in which order the act team function is called? Because if the blue team's act team function is called before the red team, won't that let them build the wall first? Well, the thing is, the only action a team can take is build walls. But it's not possible for both teams to have been able to build a wall on the same island. The reason for this is the condition for building walls. To build a wall, you have to have sole occupancy of the island as a team. If both of the pirates are on the island, that means no team has sole occupancy of that island. So it doesn't matter in which order the functions are called. The order in which the acting function is called does not give any advantage to either of the teams. Now that both teams have run their act team function, it's time for each pirate to run their team's act pirate function. The red team has a very simple act pirate function. Each pirate randomly chooses a direction to move in. First, we start with the pirate at the center of the island. The pirate randomly chooses a direction to move in this case being the right. Next, the second red pirate runs their act pirate function and they randomly choose to move down. Now we move on to the blue team. The blue team, of course, has a more involved act pirate function. We start with the blue pirate directly below island 2. The return value of the investigation function is a tuple where, who. Where can take the values wall, island, island 1, island 2, or island 3, or blank, depending on what it is, and who can take the value friend if there's a friend on the tile, enemy if there's an enemy on the tile, both if both friend and enemy are on the tile being investigated, and blank if no pirates are on the tile being investigated. In our case, we are interested in the last case, blank. So our current pirate investigates the tile directly above it. We see that the tile directly above it is obviously an island tile, but we don't care about that in this case. What we care about is that no enemies are present on that tile, neither are any friends. So therefore, the tile is blank. In this case, the blue pirate will in fact choose to move up. Notice here that the blue pirate has no way of knowing that there's a wall around that island. So it won't be able to factor that into its decision making. Now we move on to the second blue pirate. The second blue pirate once again investigates up, decides that that is a blank square or more, gets to know, and decides to move up. With this, all the pirates have run their act pirate function and have decided where to move. Of course, in this function, they could have also set signals, red team signals, but we have used simple functions that don't have these. Now keep in mind that the return value of act pirate signifies the direction that the pirate will try to move in. It does not guarantee the fact that the pirate will actually move in that direction. In our own example, let's take a look at the blue pirate near the bottom, pirate 3. We see that pirate 3 is trying to move from sea to a walled off island. This is an illegal move, and therefore pirate 3 is not able to make the move that it had planned. And in this case, it will stay stuck at the same place where it is. On the other hand, pirate 1, that is the red pirate at the center of the island, will be able to make its move since it moves from an island tile to another island tile. So it does not matter that the island is walled off. In a similar way, both the red and blue pirates that are on the right side of the map will be able to make their respective moves since they just moved from a sea tile to a sea tile. But if, for example, the red pirate near the top of the map tried to move even higher, since that is the border of the map, he would also not be able to move. The last thing we'll see is what happens when two pirates of opposite teams move onto the same tile. In our case, the red and blue pirates on the right side of the map ended up moving onto the same tile. And in this case, they have now collided. When two pirates collide, depending on the amount of gunpowder that their teams have, their fate is decided. If both teams had enough gunpowder to attack each pirate, then both of the ships are destroyed. If only the red team, say, had enough gunpowder, but the blue team did not have enough gunpowder, then the blue pirate is destroyed and the red team survives. If neither pirate's team has enough gunpowder to destroy the other, then both of them stay on the same tile. The major takeaway from this is that all pirates take action based on the same information. Of course, this is slightly wrong because pirates that maybe take action earlier in a team, say the first 5-10 pirates, might not have some information that the 11th pirate discovers and therefore won't be able to act on it. But the thing is that no team has an advantage over the other team when it comes to moving their pirates. This is because first, all pirates decide where they are going to move based on their positions from the last iteration, and only then do they actually move. Because of this, no team has an advantage in information And therefore, there is no problem of a team going first and therefore having more information than the other team. As such, both teams are equivalent when it comes to having information regarding making moves. So that was everything about understanding game iterations. Hope that gave you some insight into how the engine works. Looking forward to seeing you apply them in your strategies. Can't wait to see your scripts.